This room is cold? No, it's crazy talk.
It's colder than outside.
It's not crazy.
It's crazy talk. Please don't be crazy.
That's awesome. Pendulum.
You're drinking a frappy.
No, it's ice Americano.
Oh, well, it's still iced. Maybe this is why you're cold.
No, I mean the stairs was fine.
Did I make that mess with my coffee? Oh well. Okay. Can you all see that okay?
Yeah.
Okay, great. Let's open up the slides. So the good news is we're at the end of the mechanics section of the course, which is, bad news or good news? Usually good news, because mechanics is the largest part of the course. Some people like mechanics, some people don't like mechanics. I like mechanics.
I go to mechanical engineering course.
Yeah.
So that mechanics is what I'm gonna learn in college too, right?
You would have to do some mechanics.
I mean, based on that. If I go to electrical one, do I have to do that too?
You might have to do a semester of mechanics, but it'll be similar to what you did here. They might have you doing some general physics class. Probably will. But like I said, it should be exactly the same as what we're doing here. So I don't think it will cause you any problems. Okay, let's have a look now at the last mechanics topic. Have I got everybody? 1, 2, 3, 4, 5, 6, 7, 8. Two.
Brian.
No, I think he's going by Chu now.
Yeah, Brian.
Brian Chu.
Brian. Brian.
Huh? No. I think he prefers Chu.
Chu.
I don't know. Indeed. Right, the pendulum. Yeah. Yeah. Sean, were you able to open the physics on Moodle?
Yeah, I see it.
You can see it? You found it?
Yeah.
Okay. Continue. You have this. Does anybody know what this word is? I'm sure somebody knows. You know it, yeah. Do you know it? Yes, that's it, yeah. Pendulum is like this, yeah. So, this is the pendulum. Before you write it down, the equilibrium position is in the center, of course. We don't usually consider the rod or the string to have a mass, so we say it's massless. We usually consider this to be frictionless, meaning it's smooth, and this is not damped, meaning it will continue like this forever. Now, of course, it's a lie. The cake is a lie. This is not true, but it's close enough. It's good enough. Draw this beautiful picture for me.
You will say perfect.
Perfect picture.
Perfect. That's too American.
Perfect.
Yeah.
Awesome.
Awesome. I mean, awesome is for using like
Middle school.
I'm middle of the.
All right. Well, if you don't want perfect or awesome, you would like.
I prefer perfect.
But you just said it's too American. Oh, I forgot you're very American.
I mean, if you go to California, everyone says perfect everywhere.
In California?
Yeah, in California.
Perfect. Go to California.
Well, do you know what the Irish version of perfect is?
Grand.
Correct. You picked that up already?
It's grand.
Yes.
Grand.
Oh, come on, you must have noticed that by now.
How are you? I'm fine.
Yes, exactly. Correct, yes. It's great because you can use it anytime, anywhere. It can mean good, it can mean okay. It's so flexible. It depends on how you say it, Jerry. You know, how was the exam? Grand.
It's fine.
Yeah, yeah.
Not
Exactly.
Grand.
Yes.
How was your tummy then?
Not grand.
good.
Yeah, how was the chemistry yesterday?
Grand.
Was it? Yeah. Okay, have you drawn this?
Yes.
Wait a minute.
Yeah. Oh, come on, Bruce.
Perfection.
Perfection there.
6.
Perfect?
Yeah.
Okay. So, we're going to have a look now at the formula that relates to the pendulum. So, in today's lesson, it's a little bit of a proof. That's what we have to do. Let's have a look at that now. So, let me just switch here. So please write this proof down as I do it. We'll write it carefully. So let's draw our pendulum. Okay, and here is M here. How many forces are on this pendulum?
1, 2.
Two.
2.
So you have this one here, which is mg, and you have this here, the tension, which is T. Come in! Ah, what happened to you? Yes?
Brian.
Oh, come on. Okay. So, let's just call this angle here theta. Now, what I'll do next is I'll change this mg. I want to resolve it into two components here. So we have one this way, and we have one this way. And if that's theta, this here is theta as well. So that makes this one mg cos theta, and this one here mg sin theta. Now this is where we have to approximate. Let's say the pendulum is length L. Okay? If I draw a triangle here, this side is L cos theta, and this side is L sin theta. Okay? The pendulum moves along a path like this, doesn't it?
Yes.
And this is where we approximate. Instead of saying the pendulum moves like this, we'll say it roughly moves like this. Instead of saying this, we'll say it's like this. Now, of course, that's not true.
Yes.
But it's close. Close. In fact, if the L is really big and the distance is really small, it's actually pretty close. So we'll imagine it moves here, like this, and we'll call the distance here x. You can say sine theta equals x over L here. Also, this mg cos, it was pointing here, but now we're going to say it's like it's pointing to the left. The tension equals, sorry, I said mg cos, I meant to say mg sin. The tension is mg cos. We don't really care about this because all this does is cancel this. This is the one I care about because this is what makes it move left and right.
Yeah.
So the force here will equal mg sin theta, and it's a minus because it's going to the left. And we're saying that this is roughly equal to that. Roughly. Okay, F is ma, because of Newton. And sine theta is x over L, we said earlier. So, the ends cancel, and you get A equals minus g over L x. Now, if I say let omega equal root g over L, then we can change this into A equals minus omega squared x. And this is simple harmonic motion. So I've proved it's simple harmonic motion. So therefore, I can use the formulas that the time, t, is 2 pi over omega, which will be 2 pi over root over g over L. So finally, we get our result. The time is 2 pi root L over g. This perhaps is a formula you've seen before if you've studied this. So we've just proven this formula by using simple harmonic motion formulas. Okay. I don't know if you've done this before. So how many people have seen this before?
Yes.
You've seen this, yeah.
But
have you seen the proof? No.
But it's mass over K.
Now that's another formula, which we will also prove when we get to it. Yeah, don't worry, that's coming up too.
Oh, it's not this one.
It's very similar to this, but it's not this one.
Teacher, what is L?
The length of the pendulum. Can you write this proof down, please? Did you write this down? So Sean, what do you drink every morning? I see the coffee every morning.
No.
Cappuccino? Latte? Latte. Every morning, one iced coffee, one latte, donuts or Pringles. Can you see okay? Are you sure? You got this, Monica? Yeah? Okay, not yet. So what happens if you increase the L? What happens to the time?
Increase.
It increases. And if you increase the G? Decrease, yeah. If you decrease the G,
Increase.
so where would the pendulum need to be so that the G is smaller?
Decrease the G.
Of course you can. You send the pendulum to the moon.
Yeah.
Oh.
Then you've decreased the G. Right?
Yeah.
So on the moon, the time is bigger. Yep. Okay. Do you have this, Bruce?
No, I think I'll go to watch video.
You'll watch the video? Are you sure? Okay. Let's have a look at an example. So by using this formula, how long would it take a 1 meter pendulum to swing 10 times? 1 meter, 10 times. Okay, let's calculate it. So we have our pendulum, and we want it to swing back and forth 10 times, and it's 1 meter. So the time would be 10 t's. It swings 10 times. So that would be 10 times 2 pi root L, which is 1 over G. Okay, so that would be 20 pi over root 9.81. It's about 20 seconds. What is it exactly? It's about 20 seconds, because I know that roughly these cancel.
T is time.
T is what?
Time. That's big.
No, this is time.
This time.
Time for 1 swing.
Yeah.
Zero, 7.
20.0600751.
Okay, so as I said, roughly 20 seconds, as I thought. So that means if it was 1 meter long and you let go, it'll take 20 seconds to do this 10 times.
That's not 7,
That's a 6, okay. Which means it's to 3, it's 20.1 then. Yeah. So, not very difficult here. It's sort of a basic enough formula. You can use all the simple harmonic motion formulas as well. Because remember we said its motion is like simple harmonic motion going back and forth. So is it starting on the inside or the outside? Outside. So you could use the formula x equals a cos omega t. You can use this formula to work out how fast it's going. Yeah. The x being the distance horizontally. You can use the formula here minus a omega sine omega t as well to work out the speed. And all the other formulas as well. The only formula that's new is the one we just did a moment ago with the t equals 2 pi. But all the other formulas work. So usually what happens in the exam is sometimes they have this by itself in section A, but when it's in section B, it's part of a bigger question where they'll ask you for things like X and V and kinetic energy and potential energy and all this type of stuff. And sometimes they might even ask you for the angle. And you realize it's not too bad to get the angle, because you can use the formula tan theta equals x over no, I don't want that one, sorry. Sine theta equals x over L. Do you have a formula for x? You do. So you could say sine theta equals a cos omega t over L. So then you can have this formula. Theta is sine inverse a cos omega t over L. So if I tell you the L and I don't need to tell you the omega because you have a formula for the omega.
Yes.
So you could say theta is sine inverse a cos 2 pi root L over G T over L here. So if I tell you the L for a particular time, oh sorry, that's upside down, isn't it? Yeah, sorry, forget that. Anyways, I don't want you to write that down. I'm just trying to make the point that you can use the simple harmonic motion formulas and you can actually get a lot here. So what we'll do, I have 2 questions here. I think what we'll do is, I'll let you do these 2 questions and then I'll do them on the board. That way the mechanics is finished today and we can start doing revision. And we can start doing revision by looking at some exam questions on Moodle. Okay, so we'll get all the mechanics finished today at least. Okay, so you need 3 there. You need 2. And then you need 4. Okay, so there's 4 for them.